Hey, welcome to The Explainer. Today, we're going to tackle an absolutely massive industrial challenge that has a surprisingly elegant solution. We're going inside some of the biggest containers on Earth to see how science is making a dirty, dangerous job way safer and a whole lot smarter.
Okay, so let's just dive right in. The big question is this: how in the world do you clean the inside of a giant oil tank? And we're not talking about a simple cleaning job here. These are massive vessels at the very heart of the global energy industry. And keeping them clean? Well, it has huge implications for both safety and efficiency.
Yeah, you can forget about soap and water. The solution here is all about some fascinating chemistry that turns what was a brute force job into a precision science. It completely changes the game.
All right, so first, you really have to get your head around the scale of this problem. I want you to imagine a vessel, maybe the size of a small apartment building. Now, imagine its walls are coated in this thick, stubborn gunk that's been building up for years.
And this stuff is not just dirt. It is a nasty, hazardous cocktail of thick, tar-like substances. You've got asphaltines, which are basically the heaviest, stickiest parts of crude oil, plus waxy deposits and these tough, almost plastic-like polymers. This gunk is incredibly hard to remove, and frankly, it makes it really unsafe for anyone to go inside for inspections or maintenance.
You know the old way of doing this? It was just brutal and incredibly dangerous. It literally meant sending workers into a dark, confined space with tools like scrapers and high-pressure water jets. And even after all that effort, you could never get it perfectly clean, especially in those tricky spots like around weld seams and nozzles.
So, faced with this massive challenge, engineers had to think way outside the box. They realized that instead of fighting the sludge with more force, maybe they could use physics and chemistry to come up with a much more elegant solution. And that solution is a process called Vapor Phase Degreasing, or VPD for short. It's this high-tech, closed-loop method that completely transforms cleaning into an automated chemical process. So instead of blasting the gunk off, VPD actually dissolves it from the inside out.
This quote just perfectly sums up the genius behind the idea. Think about it. A gas can get into every single nook and cranny, no matter how complex the inside of the vessel is. Then, almost like magic, it transforms itself into a powerful liquid cleaner, right there on the surface where you need it the most.
So the question is, how does a gas actually wash away thick, sticky sludge? Well, the secret, it's all about a clever little trick with phase changes. It's a really slick four-stage cycle. First up, a special solvent gets heated until it vaporizes, turns into a gas. Then, that hot vapor is pumped into the sealed vessel until it fills the entire space. Third, and this is the key step, this is the magic, that hot vapor hits the cooler tank walls and condenses back into a liquid. And finally, that liquid, now carrying all the gunk, is collected at the bottom and recycled. It's that third step, the condensation, where all the real work gets done.
You know how steam fogs up a cool bathroom mirror? It is exactly the same idea. As the vapor condenses, it becomes an ultra-pure liquid solvent, which gives it the maximum possible power to dissolve contaminants. This creates this continuous, gentle washing action that cleans the surface right down to a microscopic level. It's brilliant. So I want to be super clear here. This isn't just a slightly better way to clean something. This is a fundamental shift in how we approach this kind of industrial problem. I mean, look at this comparison. It's a total paradigm shift. We are moving from a slow, dangerous manual job to a fast, safe, and automated chemical process that, most importantly, keeps workers completely out of harm's way.
When you really stack it up against the old ways, the difference is just night and day. Water jetting, it mostly just pushes the gunk around. Steam cleaning, that really only works on the lightest oils. But VPD, it dissolves everything from heavy crude to the toughest waxes and asphaltines. No contest.
And get this, zero gallons of water wasted. Because it's a closed-loop system that just reuses its solvent over and over, VPD uses no water at all. That eliminates a massive amount of industrial wastewater that would otherwise need really costly treatment and disposal. It's a huge win for the environment.
And another big zero for you: mechanical damage. Since there are no scrapers or high-pressure jets blasting the walls, there is zero risk of damaging the vessel's interior. This preserves the integrity of the equipment, which, as you can imagine, is a huge long-term benefit for the companies that own these assets.
So when you add it all up, the benefits are just massive. And number one, by a long shot, is worker safety.
No more sending people into dangerous, confined spaces. But right behind that, you've got huge gains in efficiency because the turnaround is so much faster and, of course, a much, much smaller environmental footprint.
Okay, so you might be thinking, it's just cleaning a tank. Why does this matter so much? Well, it's because this innovation points to a much, much bigger shift in how we can tackle these tough industrial challenges.
I mean, at the end of the day, this is about making a vital industry smarter, safer, and more sustainable. Less downtime means more efficiency, and a perfectly clean surface allows for much more accurate safety inspections, which helps prevent major problems down the road.
It really makes you wonder, doesn't it? Where else could we replace old-school brute force with elegant science? What other dirty jobs are out there just waiting for their own scientific breakthrough?